In this video, I'm going to go over several examples of simple redox reactions with you. This corresponds to page 4 of your class notes. So by simple or trivial redox reactions, what I'm referring to are those reaction types that you are probably familiar with from your first year of chemistry. And in general, by redox reaction, we mean any reaction in which the species are undergoing a change in oxidation number. So we'll probably just go ahead and start with that definition. And of the reaction types that we're already familiar with, we might think of these as our synthesis reactions, decomposition reactions, and single displacement reactions, and combustion reactions as well. So we're going to get some examples down in our notes of all of those types. So the first one we're going to look at is the reaction of a metal and a nonmetal to form an ionic compound. So this would be an example of a synthesis reaction. So I'll ask you to pause the video right now and to write the reaction for the synthesis of aluminum bromide. So pause the video and then restart when you're ready to check your answer. So the phases of the elements are given at standard conditions, and then all ionic compounds in the absence of water are written as solids. So make sure that you've balanced this equation correctly and included the appropriate phases. The next example we're going to look at is the reaction of two nonmetals to form a molecular compound, and this is yet again another synthesis reaction. So you can go ahead and pause the video as you write the equation for the synthesis of phosphorus 3 chloride. So this one was a little bit of a challenge. The phosphorus is typically written as P4. That's how it exists as an element. If, however, you may not have known that if you just started with phosphorus, you would have a slightly different looking equation. And different balancing as well, right? So we would have a 3, a 2, and a 2. Okay, this is a more traditional way of writing this equation. You may have forgotten that P4 is written that way. Sulfur is that elemental sulfur is written as S8 typically when you're writing an equation with that. Okay, moving on to our next example. So these 4 are going to be examples of combustion of hydrocarbons or organic compounds. And the products of this reaction are always carbon dioxide and water. So I always say that combustion reactions are easy to write, sometimes difficult to balance. So the first equation you're going to write is for the combustion of methane. Go ahead and pause this video while you give that one a try. Sorry, I just ran into a little technical difficulty using the pen. So the strategy for balancing a combustion reaction is to balance your carbon first, followed by your hydrogen, followed by your oxygen. So that one was a fairly straightforward. This should be CH4 gas as we see it over here. Sorry, the phase is a little bit difficult to read. Okay, so our next one for letter B, I'll have you look at writing the combustion of octane. Okay, so octane, the OCT prefix is 8. This is the main component in gasoline, C8H18. Okay, so our alkanes are 2N plus 2 hydrogens. Octane is a liquid. Oops. All right, so for the balancing, I'm going to change my color of pen here so we can do this together. First the carbon, so we have 8. Then the hydrogen, so over here, let's see, over here by the water, we have 9, which will give us 18 on each side. So then the strategy is to do oxygen. Over on the right-hand side of the equation, we have 16 plus 9, we have 25 oxygen. And over here on the right-hand side, we have 2. So in front of the oxygen, you want to do 25 halves in order to balance. Okay, now that is not a traditional equation that we would write. You do not want to have fractional coefficients for your balanced chemical equation, which means you double the coefficient of each component in the equation. So we're going to have 2 octane. We're going to have, get rid of that 2, 25 O2. we're going to have 16 CO2, and we're going to have 18 H2O. Now you're going to pause the video again, and you're going to write the equation for the combustion of glucose, C6H12O6. And this one is a little bit easier to balance. We've got 6 CO2, we have 6 water, and then we have a total of 12 and 6, 18 oxygen. On the right, we already have 6 over here on the left, so we need 6 O2 to balance that. And the last example I want you to take a look at is when the hydrocarbon, another one where the hydrocarbon contains an oxygen atom in it. Never forget to include that in the balancing. So we're going to look at the combustion of CH3OH. This is methanol. It's a liquid reacting with oxygen. All right. Again, we're going to go through and systematically balance carbons first. There's 1 on each side. I have 4 hydrogen on the left, so I'm going to put a 2 over here. Now I have 4 oxygen on the right-hand side, and I have 1, 2, 3 oxygen on the left-hand side. So by our plan that we've had before for balancing, we adjust the oxygen here, and then we see that 3/2 O2, that's going to be 3 O's, plus the O from CH3OH will give us 4. So now we're balanced, but we have a fractional coefficient. So at this point, we're going to double all of our coefficients. And that's a 4 for our last one over there. Okay, so hopefully this reaction type is familiar to you, and that little bit of practice has reminded you of the strategy that we use for balancing combustion reactions. Next slide. Sometimes you'll hear the term combustion used outside of its traditional meaning, which is combination with oxygen with an organic substance. We're going to look at combustion of elements now, which is also combination with oxygen. Okay, so metals reacting with oxygen to form metal oxides. So we'll do the example in which sodium oxide is formed from its elements. So pause and write that equation, sodium oxide. Go ahead and check your balancing, check your phases. Remember, all ionic compounds in the absence of water are solids. And so there we have the formation of sodium oxide, which is a base anhydride. Remember, if we do put the sodium oxide in water, in our acid-base reactions, we're going to generate sodium hydroxide, which is a base. All right, in letter B, we're going to look at the combination of a nonmetal with oxygen. So go ahead and write the reaction for the formation of carbon dioxide from its elements. Pause while you do that. Nothing fancy here, no balancing needed. Phases are all appropriate. And you know that carbon dioxide is called a nonmetal oxide or an acid anhydride. And when you put CO2 in water, you get carbonic acid, which is an acid, which is the component of acid rain. All right, and our final example is we're going to do an example of a decomposition in which a polyatomic ion containing compound is going to break down and cause change in oxidation number. So we're going to look at the decomposition of potassium chlorate. Go ahead and pause and make sure you can write this equation. See if you remember it. We're going to form metal chloride and oxygen. And check for your balancing again and your phases. Remember that potassium chlorate, being an ionic compound, is going to be a solid. This reaction would likely happen in a Bunsen burner with some heat. And this would be in a test tube or possibly in a crucible, something that could withstand high temperatures for this reaction to occur. So on page 4 of your notes, you should have a variety of examples of simple redox reactions. You might want to go take another look at these and note how oxidation numbers are changing, who's being oxidized, who's being reduced. We'll talk a lot more about that in the coming days, but these are some things that you should recall from the first year of chemistry. What I'd like you to do for the remainder of class time on your own, I'm going to have you work through some of the practice problems in your class notes. So please continue to proceed with practice problems 15, 16 on page 5, and then numbers 20 through 24 on page 7. Okay, I'll update that assignment in the Schoology updates, and then continue to work on the assigned homework from chapter 4. And I'll see you on Monday. Thanks, guys.